Am I audible properly?
Yes, sir.
Yes, sir.
Okay. So struct, suppose the name of the structure is person. Okay. So if you want to design our own data type, so what is the name? What is the name of our data type?
Person.
Person. Okay. So we declare here two data member. These are called the data member. Suppose age is one of the data member, and another data member is weight. So age is float. Okay. So we declare a structure person and weight. Okay. Now, if we write within main function, we want to allocate, declare a variable. Okay. Suppose we can write data type. Okay. What is the name of the data type?
Struct person.
Struct person. Okay. Then pointer. Okay. Then now tell me n into size of size of is one word. Size of, tell me, what is the data type name?
Struct person.
Struct person. Okay. So if n value, what is the size of this data type variable? Data type. If we declare a variable,
Six
suppose if we
approximately.
declare a variable, struct not 6 person. Suppose p1 or p. What is the what is the size of p? What is the size of p?
सर फ्लोट का 2 by 10 एज का 2 सॉरी फ्लोट का 4
Suppose int
एज का
a. So 4 plus 4, 8 byte. Okay, what is the size of P? 8 byte. Yes or no? This
यस
is
सर
4 byte and this is also 4 byte. So 4 plus 4, 8 byte. Okay. So if we declare one variable P of struct person type, what is the size? 8 bytes. Suppose we want to declare three variables. So suppose this is our memory or primary memory or RAM. Okay. So here this portion allocate for one variable p, this portion allocate for another variable q, and this portion allocate for r. Suppose we declare p, q, r. So how many bytes allocate total?
सर 18 सॉरी
Not
24
18.
सॉरी सर
24 bytes. So this is for p variable, this is q variable, this is r variable. What is the data type of pqr variable? What is the data type
Struct
pqr
person.
variable?
Struct person.
Yes. So here, yes, start person, and each variable contain two data member. Each variable contain two data member. This is age and weight, age and weight, and age and weight. So we can store 3 persons age and weight. Up to this clear?
यस सर क्लियर
Okay. Up to this clear? Okay. Suppose the address is here 100. What is the address of the next next block? This variable block. What is the address? 100 plus 24. 100 plus 8. 108. 108 plus 8. 116. Yes or no? From 100 to 107. Total how many bytes? 100, 101, 102. each memory represent 1 byte. So 100 to 107 total 8 byte. So P variable 8 byte, Q variable also 8 byte, 108 to 115, and R variable also 8 byte, 116 to 123. Yes or no? Up to this clear?
Yes, sir.
Hello?
Clear, sir.
Okay. So we can declare 3 variable, or we can declare yes or no value of which type? Struct person type, like int a3. It is an integer type array which can store 3 integer type value. Actually P, it is an array which can store 3 struct person type value. Yes or no?
Yes, sir.
Okay, so this is dynamic static allocation. If we allocate this, then this total 24 bytes allocate. Either we can represent, we can declare 3 different variable, or using static array, or dynamically we can allocate. So at runtime, okay, you can allocate the value of n. Suppose n value is 3. If n value is 3, so 3 into size of struct person. What is the size of struct person? 8 byte. Okay, to allocate one variable, if you allocate one variable of struct person type, what is the size? 8 byte. So 8 into 3, 24 byte allocate. If n value is 4, so 4 into 8, 32 byte memory allocate. If n value is 5, 5 into 8, 40 bytes allocate. So dynamically we can allocate. So when we allocate dynamically, we need to write an int star p. So what is if we allocate one pointer variable, suppose p. Okay, what is the data type of this pointer variable?
Struct person.
Struct person, because p is a pointer variable which holds the address of struct person type. So here you need to write p. So malloc return the base address. What is the base address? Suppose 100. So malloc return the base address and p stored that base address. So dynamically also you can allocate. Is it clear to everyone? Any doubt?
Yes, sir, got it.
Just simple like integer, int star. Integer data type, the variable data type is struct person.
Sir,
Malloc
if we don't even know the uh, number of elements we will need, then can we define it to 0 and then reallocate every time we input?
yes. If we don't know the input, then it's better to allocate at runtime. Okay, suppose we allocate a memory, suppose 30. We declare an array P. P, it is an array of struct person type. So how many bytes allocate? 30 into 8? 240 bytes allocate. But suppose you have used only 20 byte. So 20 memory block. So 20 into 8, 160 block you have used. So remaining 80 bytes wastage. So that is the advantage of dynamical allocation. If you want 8, so place n value is 8. If you want to if you want to store 10 value, 10% uh, information, the n value is 10. If you want to allocate 15% information, n value is 15. If you in your section there are 79 or 80 students, suppose you want to store the age and weight of 80 students, n value is 80. Okay, any question?
No, sir.
No, sir.
Very simple. Okay. Now,
Sir, I had another question. Sir, if we are doing in C++, then is there any other method that is introduced, or is this the best way to do it, other than vectors?
Dynamic memory allocation, there is malloc and calloc.
Okay.
Okay.
Yes, sir.
And in C++, I think if you used Unix, then you have to include alloc.h, ALLOC. Okay, alloc.h header file.
Okay.
Okay.
Thank you, sir.
Now, pointer to structure. Okay, what is P? What is P?
Integer pointer.
A?
Integer variable.
A value suppose 5. Now, we write so this is a variable A, the value is 5, address is suppose 200. So now this is a variable P, it has own address 300 and value, what is the value of P?
200.
200. Okay. So P is the integer type pointer. Now we declare, so P is a pointer which points any integer type value. P is a pointer which holds the address of any integer type variable. P is a pointer which holds the address of any integer type variable. So it's the integer pointer. Now pointer, structure pointer or pointer to structure. So it's simple. Suppose we declare first to declare, you have to declare a structure. Suppose person. This structure contains two data member. It contains two data member, int age, float, weight. Okay. So now it is complete. Now we write main function. In this main function, we declare a pointer variable. Struct person point ptr. Now tell me what is ptr? P is a pointer variable which holds the address of any integer type variable. Okay, P is a pointer variable which stores the address of any integer type variable. So that's why it is an integer type pointer. What is ptr here?
It points to a structure. Stores the address of a structure.
Yes, ptr is pointer
Person,
which holds the address of any structure. Okay. Now, and also you have declared one variable P. What is P? P is a normal, what is A here? Integer type variable. Similarly, what is P here? Stack percent type variable. Okay. So when you declare A, it's allocated memory, then you assign the value 5. You have, when you declare A, that time it's allocated memory of 2 bytes. When you compile the program or 4 byte, then we assign the value 5. Okay. So similarly here, we can declare a variable name is P. And what is the size of P? Total size of the P is 8 bytes. It has own address. Suppose address is 200. Okay. So 200 to 207. Total size is 8 byte. Each memory location is 1 byte. So 200 to 207. Total 8 bytes is the size of this variable p. Up to this clear?
Yes, sir.
Okay. Now we have another variable which is ptr. It has own address, suppose 300. What is the value of ptr? What is the task of ptr? ptr wants to hold the address of p. Yes or no? Here p is a pointer variable which is integer type. It holds the address of a. Here p is a pointer variable which holds the address of ptr is a pointer variable which holds the address of p. Can you relate it?
Yes, sir.
Okay. So now we need to write ptr equals to ampersand p. So what is the value of ptr? What is the value of ptr? According to this diagram, what is the value of ptr? 200. ptr holds the address of p. What is the address of p? 200. So ptr value is 200. So its point this block. ptr variable points this block. Now this block p variable, there are two data members. Okay, one is age and another one is weight. Okay, so I want to store the age and weight. How to store? Okay, we want to store the age and weight using this ptr. I don't want to use p variable because ptr points this location, this memory block. Okay, it holds the address, base address. Now using this ptr, how can we store the value of age and weight? Okay, so if we write printf, okay, enter age, printf enter age. Now scanf, okay, how to what is the data type of age? Integer, percentage d. Here we use this arrow operator. Okay, when you use pointer to structure, then we use this arrow operator. If we not want to use pointer, we just to store the age, so we can write p dot age, ampersand p dot age. But using pointer, we want to assign a value here in this variable, in this data member age. So how to assign? We need to write ptr, the pointer variable name, arrow, then the data member name. Okay, then address. Okay, it has own address 200. So 200, what is the age? 200, 201, 202, 203. And what is the address of weight? 204, 204, 205, 206, 207. Total 8 bytes. Total 8 bytes. The age data member address is 200, 201, 202, 203. Each block represents 1 byte. So if you want to store, suppose age is 30, okay, age is 30, so this 4 block is required. 4 memory block is required. Okay, total 4 bytes. Similarly, if you want to weight, suppose 69.8, then this 4 memory block is required. The total block is 8 bytes. But what is the base address of this block? Which is 200.
So
in
why
this way,
percent of PTR?
okay. When we use scanf, then only need to pass the address. Yes or no? Where we store this value 30? PTR points this memory block. PTR holds 200. But in this 200, where we store the age? A points this location, but this block. But why we store 30? In this location or this location? So we need to put the base address. So that's why PTR arrow age, which is 200. Okay. Now suppose printf enter weight. Okay, how to enter weight? Weight is floating type value, comma, ampersand PTR arrow weight. Okay, so what is the address? PTR arrow point this memory block. PTR arrow weight, that means what is the address? 204. So in this memory block, in this location, we insert the value 69.8. Okay, user entered the value 69.8 through keyboard. So that's why we put here ampersand. Okay, because when we enter the value PTR arrow edge, here we provide the address. What is the address? 200. We enter 30 stored within this memory block, this one. Now, when we
So,
enter the value, suppose 69.8, here we provide an address. So where we store 69.8? This memory block. Yes.
sir, in the main type of function, so we have a means declared PTR is equals to ampersand of P. And in the scan, so it is declared. Then in a scanf, we are using the ampersand of P of PTR
Hmm.
and arrow age.
Hmm.
So here we have given the address of P. Na? So address of PTR will be
Here,
means address of PTR is 300.
suppose this is your hostel, suppose KP1. In this hostel, there are two rooms. Okay. Suppose you, what is your name?
Samarth.
Samarth. Samarth point, where is KP1? Samarth point, okay, provide the address. Okay, that this is in campus campus 6 or campus 7, and you provide the address. But if you want to allocate one person here, A, and if you want to allocate another person here, B, this Samarth points this block, this hostel. But if you want to allocate one person in this room number 101, in this room number 102, how to allocate? Here, PTR point this block, this hostel. Now, if you want to store variable A in this room number 101, so that's why here we provide the PTR. Here it's allocate a hostel, and here allocate the particular room within this hostel.
Okay, so got it. Sir.
Got it?
Instead of age, can you store the address directly like 200?
Yes, instead of this, you can write it is similar like this. Ampersand. Suppose if you write PTR dot age, or you can write ampersand P dot age. P variable, age data member, address you want to provide here, which is 200. Here we can write P dot weight. But here we assign the value using variable. But here we assign the value using pointer. Using pointer, we assign the value in this particular block and in this particular block. Is it okay? Okay. Now, how to print the value? How to print the value? You can write printf simple. How to print the value? Age. How to print the age? PTR. How to print weight? Okay. So PTR points this block. PTR arrow edge means 30. So here print 30. Then PTR arrow weight, it's point this block. Then what is the value? 69.8. Instead of this, you can write here pointer PTR dot edge. Or here you can write pointer PTR dot weight. Okay, PTR is 200. Pointer PTR, this memory block. Dot edge 30. PTR, what is the PTR value? 200. Pointer PTR means value at 200, means this. Now, if you want to know only particular weight data member, so dot weight means 69.8. Pointer PTR points the whole hostel. Here pointer PTR points the hostel KP1. Okay, but dot edge points the one room. Dot weight points the another room in that hostel. Is it clear? Similarly, PTR arrow edge. You can write either this way or this way. Using pointer, it is best to use this arrow operator. So PTR arrow edge means edge data member. Okay, PTR points this block, and edge means edge data member value. PTR points this block. Weight means arrow weight means this data member value. Weight data member value. Any question? Please check once, because this is very, very important. When you write linked list program, tree program, graph program, if you have any doubt, please ask. Because I will not repeat again. If you have any doubt, please ask. When you write 2-3 program, then you can easily, it will be more clear. Okay.
Yes.
Okay. Now, we discuss another very important topic, which is called sparse matrix. Before that, we need to write another topic. Okay, just a second. Polynomial representation. One question from this topic must come in your mid-sem or end-sem or class test also. Polynomial representation. Suppose if you write is it a polynomial function? Yes or no?
Yes, sir.
Okay. What is this? 2, 3, 10, these are called
Coefficients.
coefficient. Okay, these are called coefficient. And what is this? 3, 2, you can write here x to the power 0. So 3, 2, 0. Can you write here x to the power 0?
Yes, sir.
Okay, x to the power 0 means 1. So these are called
Power or exponent.
exponent. So any polynomial function, there is coefficient and exponent. Now my aim is, within a computer, how can we represent this polynomial function? Okay. So there are two ways to represent polynomial function. One is called array and another is called linked list. Using two ways, we can represent polynomial function using array and linked list. So using array, how can we represent? Okay. Suppose we have one integer type 1D array, suppose ARR poly, and the array size is suppose 10. So we have one array ARR poly, array size is 10. Okay, so now here we need to write the index. Here we need to write the coefficient. Okay, so we have one array. What is the array index? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Total size of the array is 10. So array index 0 to 9. Now, what is the coefficient? Suppose you want to write another code. Suppose 2a to the power 7 plus some 10a to the power 5 plus 8a square plus 15a plus 21. How to represent using array? Okay. The total size of the array is 10, index is 0 to 9. Now, this part, okay, so we can say actually any general term of any polynomial is C a to the power e. What is C? C coefficient, E exponent. So how to store? The procedure is to store the coefficient C in the index E of the array. Okay, I repeat again. This is the common term of any polynomial C a to the power E, C a to the power E, C a to the power E. C is coefficient and E is exponent, A is the variable. Okay, A, X, Y, anything. Now, how to store C coefficient C? We need to store the coefficient C in the array index E of the array. Okay. The procedure is to store the coefficient C in the index E of the array. Coefficient C in the index E of the array. So now tell me where we store these two, where we store? Two, what is the index? Coefficient C we need to store at array index E. So what is the array index here? 7. So we need to store 2 at array index 7. So array index 7 we need to store here 2. Where we store 10?
In array index 5.
In array index 5.
Where to store 8?
Array index 2.
Where we store 15?
1.
Where we store 21? 21?
0.
0, 21 we can write 21 a to the power 0. A to the power 0 is 1. So 21 into a to the power 0 is 21. So we can store 21 at array index 0. And rest of the index we fill with 0. Because if we add 0 a to the power 3, 0 into a to the power 3, what is the value? Suppose with this we want to add 0 into a to the power 3 plus 0 into a to the power 4. So 0 into a to the power 3 means 0. If you multiply with 0, it is 0. So if we add 0, nothing will change. If we add 0, 0 into 10 to the power 4 means 0. If we add 0, nothing will change. Yes or no?
Yes, sir.
Okay. So if we know the polynomial function, we can represent it by array, 1D array, or if we know the polynomial, if we know the this index and coefficient, the array and what is the value of each array, then from this we can represent the polynomial function, because 21 into a to the power 0 plus 15 into a to the power 1 plus 8 into a to the power 2. Let's take an example. Suppose index is suppose 0, 1, 2, 3, 4, okay, and coefficient suppose here 7, 8, 12, 3, 9. Now tell me what is the polynomial function? Can you please tell me what is the polynomial function? Suppose using any variable. Suppose the variable is suppose x. Okay. What is the polynomial function?
9x to the power 4 plus
9x to the power 4, because this is coefficient and this array index represent the exponent. Array index represent the exponent. So we have one array. Okay. So this in this array, these are the index and these are the values. Okay. So 9x to the power 4 plus
3x
plus. Is it clear to everyone? I want to listen from everyone. Is it clear?
Yes.
Okay. So if we know the polynomial function, we can represent using 1D array, or if we know the array and the corresponding value, each index value, then we can design this polynomial function. Okay. But if suppose 9a square plus 3ab plus 5, how can we represent using 1D array? Is it possible? Is it possible to represent with 1D array? No. Why no? Because there is two variables. Using 1D array, we can represent any one variable, either x, y, a, b, anything. But using 1D array, we cannot represent two variables a and b. Okay. So let's take some example here. Here you can see polynomial function is 4x cube plus 6x square plus 7x plus 9. What are the coefficient? 4, 6, 7, these are called coefficient. And exponent 3, 2, 1, 0. So these are the exponent. Now how do we know what is the maximum index of the array? For any polynomial, suppose this polynomial is given, we want to represent this polynomial using 1D array. How do you know what is the last index of the array? What is the last index of the array? अरे brain use करो. What is the last index
Size
of
of
the array?
AR by length of it.
What? Not that much. What is the last index? We represent this polynomial using array. So what is the last index? Maximum index. What is the maximum index?
so the highest power.
Yes, highest power. Obviously. Good. Very good. Excellent. Obviously the highest power. Here you can see we represent, okay, so total, suppose this is our polynomial. We want to represent using index, array, 1D array, using 1D array. how to represent using 1D array? Using the highest index. What is the highest index is 4. So that's why array last index is 4. Okay, the array last index is 4. What is the last index? What is the highest index here in this polynomial? 4. So that's why last index must be 4. We can declare an array of size 100, 200, 90, whatever. But this is wastage of memory. If we know the polynomial and if we find the address, if we know the highest index, highest exponent value, then the last index is that highest exponent value 4. But when you write a program, then you need to allocate a large size because you don't know what is the user input. If you don't know the user input, then suppose you allocate an array, okay, you allocate an array of suppose ARR 50. So what is the highest index? The user can enter up to x to the power 49. 0 to 49, total size of the array is 50. So here, if we array size is 50, that means highest index user can enter, the highest exponent is 49. Am I clear to everyone? Any doubt?
No, sir.
Okay. So here you can see in this example, so 4, so highest index is 3, so 0 to 3, highest index plus 1 is the array size. Highest index is 3, 3 plus 1, 4, so total size of the array is 4, and highest index is 3. So 0, 1, 2, 3. So this is the index of the array. Now where we store 4? At index 3. We store 4 at index 3. Now you want to store 6 at index 2. 6 index 2. 7 index 1. 7 index 1. 9 index 0. 9 index 0. Is it clear? Hello?
Yes.
Yes, sir.
So
Yes.
for polynomial with two
Yes, sir.
variable is not possible using 1D array. We cannot represent any polynomial using 1D array. Okay. Then we can declare using linked list. Using linked list, we can represent two variable polynomial or a multiple variable. But one variable polynomial you can represent easily using 1D array. Suppose we have one polynomial 2x cube plus 3x square plus 5, 10x to the power 4 plus 7x cube plus 2x plus 4. If we want to add this polynomial, you can represent this polynomial using one array, suppose ARR 1. Okay, size is 10. You can represent this polynomial ARR 2 of size 10. Okay. Now, if we want to add this, what is the value? Tell me.
10x4 plus 9x cube plus 3x square plus 2x plus 9.
2x plus 9. Can we represent, can we write a program? Yes, I can write a program. This is my ARR 1. Okay, 0, 1, 2, 3, 0, 1, 2, 3, 4, up to 9. Similarly, we have another array. Okay, 0, 1, 2, 3, 4, 5. Okay, 0, 1, 2, 3, 4, 5. What is the last index? 9. Okay, what is the last index? 9. So this is my ARR2. Now we need to store the result value in another array, which is ARR3. So this is 0, this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, and 9. Now, how to represent 2x cube? 2 stored here, 3x square, 5. Is it correct? Yes or no? We
Yes, sir.
represent this in this. Yes. Yes. Hello.
Yes, sir.
Okay. So 10x to the power 4, 7x cube, 2x, 2x, 4x to the power 0. And rest of the fill up by 0. Now how to add? This 0th index value 5, this 0th index value 4, 5 plus 4 9, we store ARR 3 0th index value. 1 index value 0, 1 index value 2, 2 plus 0 2, so 2x. 2 index value 3, here index value 0, 3 plus 0 3, stored here 2 index value, so 3x square. 3 index value 2, 3 index value 7, 7 plus 2 9, 9 stored at 3 index value, 9x cube. 4th index value 0, 4th index value 10, 10 plus 0 10, store here 4th index value 10x to the power 4. Okay? Any doubt? Means here always remember index represent the exponent. Index represent the exponent. Now if you want to multiply, if you want to add, you can do easily. You need another resultant array. Okay? You need to declare another array where you store the result. So 0th index value here 0th index value, if you want to multiply, add, whatever you can do, and we can store within this resultant. So here also index represent the coefficient exponent, here also index represent the exponent, here also index represent the exponent. So we know when we add, if our exponent is same, then we add 2 plus 7 9. So 2 plus 7, 2 index value 3. No, 3 index value is 2, 3 index value is 7, so 7 plus 2, 9, and stored at 3 index value. So here I value, and here I value same. ARR1I plus ARR2I. So where we store ARR3I. I represent the index. Okay, any doubt?
No, sir.
Similarly, we can multiply. If you want to multiply 10 into 2x cube, so 10 into 2, 20 x to the power 7. 20 x to the power 7 plus 10 in x to the power 4 plus 3x square. So 3 into 10, 30 x to the power 6. So similarly, if you keep one array fixed, then multiply with other array. So 4 into 5, 20 x to the power 0, 4 into 0, 4 into 0, 0 x to the power 1. Okay. Sorry, 4 into 0 x to the power 0 x to the power 1, 1 plus 0 1, 4 into 3, 4 into 3, 12, 12 x to the power 2 plus 1, 3. Okay, need to store at 3. So when you multiply, then we also add the index also. You can see 10 into 2, 20 x to the power 7, 10 into 3, 30 x to the power 6, 10 into 5, 50 x to the power 4. So when you multiply, we also add the exponent. So similarly, accordingly, you need to fill up this resultant array. Okay. So if we know the polynomial function, we can represent using array, or if we know the array, we can derive from this array this polynomial function. And also we can perform polynomial addition operation and also multiplication operation. Here you can see 1 into 5, 5 plus x into 0, 0 into 1, 0, 10 into 1, 10x square plus 6x cube plus 10x plus 0 into 2, 0 plus 2 into 10, 20x to the power 3 plus 6 into 2, 12x to the power 4. So if you multiply them, you can get this value. Okay. Have you got the logic? Yes or no?
Yes, sir, got it.
Okay. So next class we will discuss some matrices like sparse matrix. Okay, sparse matrix, and sparse matrix also classify with two different matrices, triangular and tridiagonal matrix. Then we start a linked list. Okay. One 101 Amlan Bhattacharya. Amlan Bhattacharya absent. 119 148 165 168 168 present.